Hi, welcome to Upward Bound Physics, Day 5 on perfect projectiles. Perfect projectiles are motion at angles, and it's way simpler than it looks. So you're going to be given an initial velocity, 30 miles an hour, at some angle. Okay? The velocity immediately needs to be broken into two components so that you can identify v0 x and v0 y. And you use trig, cosine and sine, to break them apart. Then you have to realize that now you're looking at an xy graph. And that xy graph is going to be a perfect parabola. And the motion is accelerated. However, acceleration is constant and it's always down. Acceleration is always a negative 9.8 meters per second per second. And the horizontal or the x component is constant. The y component, the vertical component, is accelerated. But the horizontal and vertical motions are independent of each other, but they have one thing in common, and that is time. So, analysis of motions. X direction is constant motion. Y direction is accelerated motion. There is no air resistance. We play in a perfect physics world. So what is the trajectory? We'll talk about that. How do you find the total time of the motion? What is the range? What is the maximum height that this thing will reach? And then what is the final velocity, meaning put it back together. So these are the equations that you are going to need for calculating acceleration, velocity, and displacement. We'll talk about time in a second. So here's trajectory. Trajectory means what is the what is the actual angle? This is what you're given, right? You're given that particular velocity and angle. So you need to find the x and the y trajectory. You can eliminate time from both equations and essentially end up with the equation of that parabola being y is equal to bx plus ax squared. That is the trajectory, the equation of that parabola. The total time is found by taking your y equals equation, realizing that your final height is 0 after an interval of delta t. So solving for delta t, we get this equation here. The range is found by taking x being equal to v0 t cosine theta, so that delta x is actually v0 squared sine theta cosine theta divided by a negative g. That will give you the range. The horizontal range conclusion is that a 45-degree angle gives you the maximum range of anything that we would have tested. The maximum height is found using this equation, and this is the derivation of that equation. Vi squared sine squared of theta divided by 2g. That will give you the maximum height. So, final equations that you need, total time, range, and maximum height, definitely need to be highlighted because you're going to use those over and over and over again. Same thing here, just phrased a little differently. We may need to know the vertical and horizontal components. We may also want to know the overall velocity at the bottom. Thanks for watching.